You are, come on. There we go. You're on air.
Thanks a lot. Cool. Hello and happy Pi Day, everyone. So I'm not sure if you've noticed, but today is March 14th, 2016. So 4-digit Pi Day. It's not often the case, very rarely actually. And today we have our 5th talk of this Unlocking the Digital Humanities series. And we will talk about e-learning and computational language research in 40 minutes. So that's normally probably a topic that can spread over a whole semester or even 2. So I will gloss over some of the things, but please hold me accountable at the question time if you see some imprecision or you want to know about a certain topic a little bit more. This is a talk that is structured in 3 parts. First, I talk generally about language teaching and learning and how you normally do it. Then we go to something completely different and talk about computational methods in language research. And then we go back to e-learning. And hopefully in the end, it makes all sense why all those 3 things are interconnected. This is a talk that is very much connected to my biography. So I'm now an assistant professor in computer science, but I have been a trained philologist, and that for a very, very long time. It started in attending a classical high school. Classical high schools in Germany are very old and often very stern and strict, and you have Latin, you have ancient Greek. My high school was founded in 1545, and I learned a couple of languages there. I learned Latin. English was my second language, second foreign language, not my first one. Ancient Greek and a little bit of French, but more as an extracurricular activity. Then I went on and decided, okay, I don't really want to do Latin and Greek anymore. I want to earn some money, and I studied economics. I did this in Leipzig. And what not to learn in the former GDR if not Russian. So I started to learn a little bit of Russian next to my economics degree. And I also tried to travel lots and spend some time in Morocco and picked up some French in Morocco. That's also where I realized that the most important words in French is le truc and a couple of verbs. You can say everything with that and you can get along very well. But then I switched again, decided to become a high school teacher instead, and went back to the roots and studied Latin and Greek. I had to learn another foreign language to a certain level as well in this study course, so I learned Italian. I did an internship at another classical high school. This one was founded in 1212, and so it's just had its 800 years anniversary. And you might have heard of it. It was the Thomasschule in Leipzig, the school Johannes Sebastian Bach was cantor at. I did a little bit of high school teaching there. Then I also did a little bit of teaching in ancient Greek to university students. So always language acquisition, always eram, eras, erat, eramus, eratus, erant, and stuff like this. But this was not satisfying for me because I wanted to know more about the language itself. I wanted to research Latin and Latin literature, not only to teach it. So I went on and did a master's and learned more Latin and Greek and also history and numismatic and epigraphy and codicology and paleography, and ended up doing a PhD writing a very, very old-fashioned traditional commentary. And then I somehow drifted off into digital humanities and researched some English literature and digital history and stuff, but I also taught next to that German to New Zealanders. So a lot of language learning, language teaching, and a lot of experience what not to do and what to do, and why some things work and why some things don't work. That's actually an original picture of my 2 Latin teachers at this classical high school. No, of course not. I mean, that's from a movie. It's called The Feuerzangenbowle, a movie where a person who's already graduated from high school goes back into high school in order to play a prank on teachers and ridicule the high school system a little bit. It's very frontal teaching, very much teaching the language in a way that the teacher says something and the class repeats and so on. And it looks like the 50s and 40s, and that's all right. But to some extent, we're still teaching sometimes like the 50s or 40s. It's no corporal punishment anymore, sometimes unfortunately so, but that's, I shouldn't say that. I'm on air actually. Anyway, cut this out, the last one. But there's a lot of extrinsic motivation to the student learning process. There will be some Monty Python references. I hope that's not too bad for an American audience. That is Latin teaching, and a lot of students that went to Latin school actually feel like this in their Latin teaching. Yeah. Romanes, e und domus. How many Romans? Romani. Yeah. So what's the imperative? Ite. Yeah, that is exactly how a lot of students feel in high school Latin. And then we do have another thing that's already true for Latin or ancient Greek. We have a lot of made-up sentences and dialogues. It's always, every language school starts, Privyet, меня зовут Thomas. Konnichiwa, watashi wa Thomas-san desu. Ni hao, whatever. So we have always salut, je m'appelle Thomas, and so on. Yeah, always the, and I've never needed to say je m'appelle Thomas or watashi wa Thomas. I never needed to say that, because people ask you for your name and then you say Thomas. That's all you need. So, and this actually also exists in Latin. So let's go to this. It's actually quite fun to see.
Isabella, Isabella.
So this could be any language. Could be French, could be Spanish, could be ancient Greek. I haven't seen an ancient Greek version of that yet, but the mere fact that a Latin version exists already tells us a lot of things. That is a learning DVD produced in no other country, of course, than Germany, that talks a DVD length in Latin. It has a story and learning games to it and so on. It's quite interesting as a novelty. I have not seen it used very well in class yet, but it does exist, and it's all made up dialogues and made up Latin. Yeah. We do have repetition, a lot of it. Yeah. So we, as I said earlier, mai sei tai, matter is tai. We always try to regurgitate endings and schemes, and some of them we never used. Who has done ancient Greek in this room? How many duals have you encountered in your life? Yeah, okay. So it's how many duals have you learned? So, I mean, it's how many future conjunctives, they actually occur quite often. Future exactum conjunctive have you encountered? Or not also not so many. So it's, there's a little bit of repetition and learning we always use and we never really need. So it's really hard to differentiate what do we have to teach in order to learn or to read a certain text. And then people came along and said, e-learning. E-learning is everything, but e-learning per se is not the answer. I mean, you have encountered Sakai. All of you have Sakai as what Trunk is based on. Yeah. Apart from Sakai, there's also Moodle and Blackboard. I think that are the three most dominant content management, teaching content management system. That's all they are. They're not e-learning, they're no revolution in learning, they are a basis to communicate with the students in a more organized way. And you can do a lot of stuff with Moodle, you can do a lot of stuff with Blackboard, you can do a lot of Sakai. Actually now Moodle is the most versatile because it's open source and has a lot of developments. But it's nothing revolutionary. So I thought about things I learned at Teachers College, and I also read in some books. And there are some truth, and I'm not sure how many teachers in this room will agree or disagree with that, but time spent learning is correlated to learning success, always. Yeah. I was very fortunate to have it very, very, very easy in high school. I only needed to read a page once and could score an A+. But if I would have spent more time learning, I would be a more clever person now, yeah, or more educated person. Sometimes the testing itself doesn't mean that it couldn't go higher. Yeah. Time spent learning is correlated to learning success is always true, at least in all studies I've read. Motivation is correlated to time spent on a task. I think that's a no-brainer. Yeah. So the more motivated you are, the more intrinsically motivated you are, the more time you will spend doing this task. And intrinsic motivation beats extrinsic motivation all the time. Our professor in pedagogical psychology, that always happens at 7 o'clock in the morning on a Wednesday, always told us in the beginning of every 90-minute lecture that we're only there in order to get the certificate, so we can tick it up from Teachers College. That is not a very good statement at 7 o'clock in the morning in winter, but he still did it. I'm not sure if he did it on purpose or in order to test us, but it worked. It worked on me. Instead of going to this lecture, I bought his book, read his book, passed the exam, never went to a class again. The question is this the kind of teaching we want to show, or if this is something else? Then we have peer-to-peer learning is very effective. I mean, everybody knows that as soon as you actually have to, most Greek teachers probably only learn Greek when they start teaching Greek. Yeah? Really learn Greek. I mean, Greek is fairly complicated. And if you have to prepare for all kinds of student and pupils' questions, then you actually really learn something. And if you have to be able to explain something in different words, then you can read up in a grammar, then you have understood the topic. So explaining, understanding, trying to explain it to another student is the best learning thing that can happen. So that's definitely something we need to facilitate. And they told us be a motivator, an entertainer, and a facilitator. And it should be clear that not everybody there is out there to be a motivator, and not everybody is there to be an entertainer, but everybody can be a facilitator. So if you want to teach, if you want to become a good teacher, and you're not very entertaining, you do have a problem. But you can address this problem by trying to facilitate a good learning environment. And that's in the end where we want to get with our automated learning tools. We don't want to be better than the best teacher. We will never be better than the best teacher. Good teacher is always good, but we hopefully be better at some point than the worst teacher. Yeah. So that is one of our goals, and there's a few thoughts to blend over to something completely different. Yeah. I'm a big Monty Python fan. We go into computational methods in language research. And computational methods in language research is nothing else but computer-aided text analysis. So what is text analysis? Text analysis is nothing else than an analysis, which means the resolving, the splitting of text into basic units, for example, morphemes, words, lemmata, yeah, lemmatizes the text in a certain way, and then trying to bring them together again, the thin feathers. So reassemble these words, maybe adding some extra information. That's all there is. Yeah. That's also the reason why in classical commentaries or so on, a lot of lemmatization of this commentary is inherited from one commentary to the next commentary. Because one of the hardest questions is, what should I explain? Why should I explain certain things? Why shouldn't I explain other things? Yeah. So in order to pick the analysis, the splitting of the text, and then the reassembling of the text, that's text analysis. And we do that with computers. So it's computer-aided. But it's nothing new, nothing to be afraid of. And from computer-aided text analysis, or in general, we have examples. We can have a metrical analysis of the sentence. What are the length and shortenings in a verse, in a sentence? Why are there? Is there a prose rhythm? Is there a certain verse? Why is the translation written in a iambic trimeter, but the original is in a hexameter? What are the reasons for that? And trying to split this into parts. We have a morphological analysis. Yeah? What is say and what is said and what is says? Yeah? And why is this difference and how can I explain that? We have morphosyntactic analyses. For example, tree banking, you saw it already last week and probably, yeah, last week, and I think tree banking is fairly common at Tufts in the classics teaching environment. Just trying to determine which word depends on which word and try to give it the right tag, the right morphological analysis, and so on. Translation alignment is splitting two texts into different tokens and then trying to combine those again. And named entity markup is also, again, a different tokenization of the same text. So all of this are different versions of the same texts, but they're just added with different things, yeah? Theoretically. And that's important, and that doesn't really differentiate them from computer-aided to non-computer-aided text analysis. But if we have a clear identifier in place, we can refer and connect those different versions of the text quicker in a more meaningful way. That brings me to text analysis systems. That enables us to search large text and corporate quickly and also do some complex searches that wouldn't be as easy to do by hand, maybe sometimes without an index. Most of the classical words have indexes in the back, and that's also a very handy way of doing the same thing, but this can be in a more complex way. We can visualize the results, so we better understand the text corpora, and that is sometimes a different visualization than writing another monograph. So thinking a bit outside the books. And that brings me to to one of the more complicated text analysis methods, and one I favor personally the most, and that's topic modeling. Who has heard of topic modeling before? Okay. Has anyone heard of the back of words principle? That's good. So I'm not reiterating stuff. The back of words principle was developed in the 50s, roughly, by Zelig Harris. It's a simplification of text, which means if we talk about a certain topic, or if we talk about in a certain document, or we have a certain text, or a certain corpus in front of us, we have a back of words. Yeah? And if we talk about another topic, we have another back of words. Yeah? And the same, and the word order and grammar doesn't matter. So you have just a back of words, bam, that's your document A, another back of words, document B. Because the meaning itself, or some of the meaning itself, is in the word itself as a carrier and in the context, which that means the other words that are around those words. But it doesn't really mean, it's not really necessary that one word is a direct neighbor of the other word. Yeah. Sometimes for other analysis that is necessary, but for the back of words it doesn't matter. Yeah. And so grammar, word order, and so on doesn't matter. The good thing about this is that homonyms are not a problem for an approach that is built on back of words, because more important than the visual appearance of the word itself is the context. What bodies is this word with, and with the other words? Yeah. With which other words does this word hang out, and not what is this word itself? And topic modeling is has really taken off in the digital age. So from 2002 onwards, the point when there was more data stored on digital devices than on non-digital devices. And it tries where collective knowledge continues to grow, it becomes more difficult to find what one is looking for. Yeah, and that's normal. I mean, suddenly I have to read 20 billion words in order to make sure that I still work scientifically sound. Because I know I have all this information suddenly available. And now I have to find a way of narrow down what do I want to look at with quantitative methods? What do I want to look at with qualitative methods? Hashtag talk last week, hashtag look it up online and watch it again. So topic models are more than a search and link approach, because you don't try to, you actually don't know what you're looking for, what word pairs you're looking for. You, topic modeling works the other way around. You give a set of topics, and then it tries to build up the bag of words. You pretty much just only say, how many bags are there? And zooming in and out is possible with topic modeling, because you can always facet using topic models and then rerun everything, and then you get a better result. The good thing is topic models algorithms do not require prior annotation or labeling of the text, which means computationally they might be more expensive than other methods, but from the human being time spent in front of the computer, they're actually cheaper. So no annotation, nothing, no information. And topic models try to discover the hidden thematic structure in large archives of documents. That sentence needs to be a bit of a caveat, but I will go deeper into topic modeling, and then you will hopefully understand a little bit better what I mean with this and why I think that this sentence is a bit of a caveat. So what is topic modeling? You probably still don't know, really, after this first slide, because it's quite a complex topic. It's a method to find clusters of words in large bodies of text. So a topic in topic modeling doesn't mean topic what a human being means topic. In order to differentiate those two, I will call the topic that a human being would define a theme, and the topic that the topic modeling algorithm finds is a topic. There are clusters, and those are called topics. And a topic is nothing else than a recurring pattern of co-occurring words. Yeah? And we don't know what pairs co-occur together, but this is just a group of words that occur often in each of our documents. Yeah, or not always in each, but in some of our documents. So topic models are probabilistic models that are often based on the number of topics the corpus being assumed and fixed. So we often have to say this corpus has 15 topics in it, this corpus has 13 topics in it, and this topic, this corpus has 17 topics in it. And that is one of the theoretical problems of topic modeling, how to estimate the number of topics ideally. Not exactly, not precisely, ideally, because that can differentiate from use case to use case. But once you did all this, it actually becomes very precise. I don't have a link there. This is a topic model of a translation of Thucydides. So we have here topic number 4, ships, fleet, sails, Chios, Miletus, Peloponnesians, sea, sailing, sail, vessels, and so on. That's a clear topic. Yeah. So it's even a clear theme. Yeah. We know that all those topics, all those documents that have a high score in this will have something to do with the Athenians or the Milesians or the Peloponnesians sailing somewhere and maybe having a sea battle or whatever. Yeah, it's really clear. It is coincidental, a little bit coincidental, that the theme equals the topic. Yeah, a theme often consists out of more than one topics. Yeah, but ideally you have great themes. And this is a topic model visualized. So, and if I don't see a cluster, but I actually see a distinct term, then that is a good sign that they built a clear topic as well. So this might be a theme that's built out of more than one topic, and I have to look at both of them. And this is just a way of visualizing the topic modeling and then try to calibrating it. There are different ways out there, but they take computationally longer, and I also don't find them as flexible. Important thing to say is better data and simple algorithms often beat complex analytical models. Yeah? And that's not me who says this, it's actually Google who says this. Yeah? Peter Norvig says we don't have better algorithms, we just have more data. Yeah. And here we have in this paper of Benko and Grill from 2001, the blue one is a very naive Bayes algorithm. It's a very, very simple probabilistic algorithm. And we have memory-based algorithm, which is the computationally more expensive algorithm. And if you look at the million of words that are induced into this, into the learning process and into the algorithm process, you see how the naive Bayes algorithms by under 1 million words is the worst one. But if you put in 1,000 million words, it's the best one. It's computationally the cheapest one. And the more complicated one, memory-based one, ends up to have the worst results. And that is, of course, the reason why the more complex algorithms are, the more likely they are overtrained to a certain use case. Learning with a more simple algorithm, if you have a huge number of data, is often better. So let's start, or let's focus on the latent Dirichlet allocation, which is a topic modeling algorithm. Latent Dirichlet allocation. What does it mean? Latent Dirichlet allocation means that there is a Dirichlet distribution, and that is hidden. Yeah? So we try to find, we say for the generation of this text, there was a Dirichlet distribution that is hidden. And that is a process of statistical inference. So deducing properties of an underlying distribution by analysis of the data. That's what statistical inference means. That is what lies under it. So we assume that there's a Dirichlet distribution by analyzing the corpus, the words in a corpus. We know that there is no Dirichlet distribution. Yeah? What a Dirichlet distribution for creating a corpus basically means the writer has in front of it 17 bags of words and say, today I would like to write a document about ships that are fighting against each other. So I take topic 3, 5, 17, and then randomly I grab in it and throw words on my document. That's not how writers write. Yeah? Ideally, it's a bit of a Pollock writing, I think. Would be interesting to do that. But it still works. Yeah? It's a probabilistic distribution over all possible multinomial distributions. That's what the Dirichlet distribution is. Sounds difficult again, but what it says is that we don't know what those 17 bags of words are. And we don't know what the distribution is in the corpus, in the bag of words, because that's a theory behind it. In the end, it's a bag of words. So we don't know if for document 1, topic 3, 15, and 17 have been used, and for document 2, topic 14 and 1 have been used. So we don't know anything about the distribution. So we try to assume the number of topics that are out there, and then try to find out which multinomial distribution is the best, most harmonic distribution for this corpus. Multinomial distribution, if you write it down, is nothing else than an Excel sheet. Yeah? Case 1, 16 times. Case 2, 17 times. Case 3, 15 times. Yeah? You can visualize it wonderfully. But the fact that it's a statistical distribution means you don't know what it is. So it's a little bit more complicated than an Excel is, but also not really. So what it says in the end, the Dirichlet distribution, is that for each document you draw a topic distribution. So we have we have document number 1, and I draw a random collection of bags of words. Yeah. And then for each word in the document, I choose of this a random topic of those, and I grab into the bag of words and throw it on the corpus, yeah, into document 1. And that's the way I write document 1, that's the way I write document 2, and so on. In the end, it looks like this. Yeah. So we have here seeking lies their genetic necessities, and we know that there are words from 3 bags of words in there, and we throw them on this page. Yeah. So The latent reallocation is a simplification of how the documents in the dataset were created. So we know that's not the way a corpus or document is written. The documents are back of words, so the word orders do not matter, and we couldn't write the corpus in that way. We can only assume that are the words that are in this text, but we couldn't bring it into the right order. The order is completely unimportant for us. That's a good thing. And each corpus has words from a number of known topics, and each document has words from a number of known topics. And we do not know which words belong to which topic. The algorithm also doesn't know. But because the algorithm looks a lot better on the context of the word than on the word itself, it's very good at differentiating homonyms. So the word panel in document A and panel in document B are not necessarily the same word. They look like the same word, they're homonyms, but they don't mean the same thing. One thing could be a literal panel, and the other one could be a panel as a deciding gremium. So, but topic modeling has no problem of assessing that. So, this is how it works. This is the probabilistic generative process. So that is the Dirichlet distribution. They have those two topics, and they throw words into document A, document B, and document C. We have money, bank, loan, bank, money, money, bank, loan. And then we have money, bank, bank, river, loan, stream, bank, money. And then we have stream, bank, river, stream, bank. So with this, we have one topic that's a bit mixed. The computer doesn't really know what to do with, and the human being as well. But we have two very, very clear topics. We have the money bank loan, and we have the river bank stream, and so on. So and the word bank is clearly differentiated. And in the statistical inference process, we have those texts, we have those banks of words, and then we try to determine, and we have the number of topics, and then we try to determine which words do belong to which topic. Logic? Yes, hopefully, a little bit. So the central goal of topic modeling is to automatically discover the topics from a collection of documents. So you have the number of topics, you have the number of documents, you know the documents, but you try to come up with a very nice distribution of the topics. So the central inferential problem for LDR is determining the posterior distribution of the latent variables given in the document. That sounds very complicated, but it's actually fairly easy. So success and results of an LDA rely on priori set variables. The number of topics, the number of iterations the algorithm goes over it, the normalization of the data, stop words. Normalization of the data, for English, it's very easy. For Persian, it's very easy. For Greek and Latin, it might be very complicated. Because Greek is a morphologically complex language, and we have to find a way of how can we harmonize the different morphological appearances of the same token, of the same word. Topic modeling is very, very good in homonyms. Topic modeling is not very good if there are 36 different versions of the same token. So we try to harmonize this. The more data we have, the less harmonizing we have to do, by the way, as well. So if Perseus and Leipzig would digitize even more Latin and Greek, and maybe also start writing some Latin and Greek so we get more data, then this wouldn't be a problem as well. I already did that. So here we have a practical example. Why doesn't it? Because I have to go there. So if you want to run this is my GitHub account, and you can actually see that there's Arabic topic modeling, cartoon topic modeling, some Greek, some Latin, some Persian, some Petronius, and so on. And if you want to have a quick view on your own computer, install R, follow those 5 steps, and enjoy. But I can also talk you through. This one is actually topic modeling based on Digital New Zealand API craze. So it's going through descriptions of library items. And you have a number of variables you as a user can set, and then you can just start the topic modeling. And all the programming and everything is already done for you. And then you can submit this and you can download it. And you can look at your results and you can download the data as well. And you can actually influence the number of topics and the number of terms shown and the number of iterations. That's possible. And that means the calibrating of the microscope, or macroscope if you so wish, you do yourself. Yeah? The algorithm doesn't do it for you. You as a researcher have direct influence on doing it. And that enables us in some fashion, either in a graphical user interface or just directly doing the coding in R, to do topic models for all kinds of text. Persian, Arabic, Latin, English, completely language independent. So this in the variables you as a researcher could directly influence, either in the graphical user interface or in the code. You can do, of course, in the code even more. You could change the algorithm to another algorithm. You don't have to use LDA. Here we have another example. You saw the translation beforehand. And now we have the same, hopefully the same topic. No, it's not the same. Here we have one. I think that's good. Nous, yeah. We have nous, the Greek word for ship, pleo, epipleo somewhere as well. So it's, yeah, we have epipleo and so on. So we have pretty much the ship topic in sailing shopping and so on in Greek that we had in English before. And if they're topic modeled the same way, they have a certain characteristic distribution of the different topics, and you can actually use this in order to find the translation of one text to another. This is all still very experimental, but it does work. What also, of course, works even better is if you have stable citations that enable you to search with less annotation effort. So if you know this is the same topic in Greek as it is in English, because it's the same passage, then you can actually use this to compare it. Yeah? The most important thing, though, I want to say is that topic modeling is not an end, but a means to an end. So the question is not, can we do it or not? The answer is easy. Yeah, we can. We can learn something about our data. We can learn something about our corpus looking through this macroscope of the topic modeler. But what can we actually do with the data? That is the bigger question. And again, now for something completely different. Let's talk about e-learning. 2 years ago, we decided, or 4 years ago, we decided to develop an application for learning Thucydides in ancient Greek. It was called Phaedra. Then it was called Ancient Geek. It is pretty much a platform that enables you to learn ancient Greek in your own way. So you have self-guided learning, which means you were actually selecting yourself what of the text do you want to learn, which grammar topic do you want to learn, how quickly do you want to learn that, and so on. We incorporated things like tree banking into Phaedra itself. And you could test yourself on tree banking. You can morphosyntactic annotate the text. We had translation alignment and testing translation alignment and trying to give the user direct feedback if they have aligned correctly. And we could track the learners and the annotators' progress in doing all of this. So that's good, and it's data-driven. And this data-drivenness of it, it's an advantage and a disadvantage. The disadvantage is that adding new text in languages needs a lot of work, a lot of development, a lot of pre-banking the new passages, a lot of text alignment, localization in different languages. Ancient Greek was localized for English, Italian, Arabic, German. Yeah. So to keep all of this afloat is a lot of development effort. And it was a nice prototype project, but it takes a lot of work. Yeah, that's why we retired it for a while. It's still in the drawer. We might pick it up at some point, put it back on the desk, and try to improve it. But there's some computational thinking behind it that's probably better to follow a different approach. That actually brings me to my last topic, what I did in my 6 weeks at Tufts. So I supported Professor Crane in building a course for Thucydides. And that was an individual course built solution. And I'm happy to see some students of that class as well. And I hope they don't throw apples or rotten fruit at me for bringing this up. And we used a number of digital tools that are out there. We used the Perseus alignment as implemented in Perseus. We used Arethusa tree banking as implemented in Perseus. We used Dolphin API, developed by my colleague in Leipzig, Giuseppe Celano. We used my topic modeling. We used the Morphos API, originally developed by Perseus, now hosted at Perseus. And we used some trunk stuff just to communicate with the students. The latter could have been anything. One of my student groups back in Leipzig founded a Facebook page in order to communicate with each other. With each other, not with me. That's the important bit. Yeah? So you try to facilitate peer-to-peer exchange and learning because they learn more from each other than they actually learn from you. That is a student alignment. That's a screenshot of a student alignment. But all these words and all this, it's anonymized, all these words in English and Greek are aligned to each other. So the students know exactly which word means what. And that also creates new data that we can use later in order to generate more learning tools. Yeah? So that's not schoolwork and homework for the bin. I'm not interested in reading homework or schoolwork that I've read every year and every semester. I prefer to let them do something positive with their time. We have the tree banking. That's the tree, annotated up to everything. And we created this Google Doc just to try to foster a little bit of peer-to-peer exchange. So they do have the different identifiers for their trees, and they can then use the Dolphin API in order to see what's different. So I'll show you some of it. So here is, as I said, the aligned translation. And I think here we have the tree, nicely annotated what belongs to what. And here we have the result of the Dolphin API, where you actually see there are two students' annotations. And the students' annotations are differ in 10 tokens, in 10 words. And then they actually, ideally, they look through their own annotations and then see what is annotated the same, what's annotated differently, and think about why. And hopefully also have a discussion about why this is differently annotated. Yeah? So you can download this as an XML, you rename it into HTML, and then you actually have this for yourself. So it's all about trying to extend the peer-to-peer learning process from the classroom outside of the classroom. It's easy to do group work or something like this in class and have them talking with each other, but how to facilitate a way that they have the possibility to continue this process outside of the classroom. And that's all great, hopefully, but how can we test them? That's the other question. And that's where topic modeling came in. Because we wanted to test them on sight readings. This means we want to test them on passages they have never encountered before, based on the passages they have already encountered. And that's not new. That's also not rocket science. That's what teachers do for a very long time. But the sight readings generated by the individual teachers or individual gremia, they are based on individual judgment by the teachers. They're not based on hard numbers. So So we thought we just built an app for the course. Yeah. And we built an app that is called Site Reading Finder based on topic modeling Thucydides. Tufts, GRK 0103. Yeah. The theory behind it is that we topic modeled Thucydides. And then we used those topic models for each passage in order to find how similar is their topic distribution, their topic structure, in order to find out how similar are two sentences to each other. And that works quite well. It takes a bit of time, but it works quite well. Runs automatically, so the computer takes a lot of time, not I. And then we also try to morphologically normalize the Thucydides using the Morphoise API, so we pass it. And because we always have a result that is bigger than 1 from this Morphoise API, one word can mean different things, we try to generate a guesser, an analyzer who is guessing the most likely form, not of all over the Greek corpus, but for that text. Yeah? So each word becomes a vector of words, and then we just count what's the most frequent in this chapter, in this book, however precise we want to calibrate this morphological analyzer. And then we put it out into Shiny. Shiny is an R library that helps you to develop apps in R very quickly, like that. Yeah. The app was written in a day. All the computation that went on before that took a weekend. So that's 3 days for personalized, individualized app for a course. Yeah. And this is how it looks. It's a bit slower than normally. Here we go. So the students can see the topic model of Thucydides here in the background, and then they can choose any of the sentences they have encountered in class, and they can generate any amount of sight reading passages from 1 to 10, and they submit it, click on sight readings, and they do have their sight readings. And the word in black is words they have already encountered in their sentences, and the word in blue is words they haven't encountered, and that links through to the Greek word study tool of Perseus. Yeah. And this is a very, very quick application, as you can see. I'm using it live right now from the internet. 3, I want to submit 10, boom. Yeah. So it's, and we tell the students, you use this to prepare for your midterm, because we will use to select your midterms from this application. So if they actually prepare themselves for 5 times all the sentences, all the passages they have encountered in class, they will definitely get 100%. But it's probably a bit of a time problem to prepare for all of them, but at least they have the possibility to prepare for most of them and see that. We can visualize a similarity between sentences. I'm not going, just due to time constraints, to explain what this similarity here means, but we can actually visualize how similar passages to each other are. And we can do that over a complete section as well, of more than one. Yeah. Oh, sorry. So why do we do this? Develop time for any pair of authors is less than 2 weeks. Any pair of authors. With Phaedra, Ancient Geek beforehand, we had a lot of development time for each author to implement that, a lot of funding and so on. Here, give me a pair of 2 authors or 3 authors, doesn't really matter, and I can generate that within less than 2 weeks. It's language independent because topic modeling is a language independent tool. You can do that for Latin, Greek, French, English, Italian, doesn't matter. It's combinable with all the tools we already have. Alignment, tree banking, course communication, course content management system, and so on. The only requirements you have is that you use stable identifiers. That is not even a strong requisite, but it's a wishable thing, a desirable thing. and you have a morphological analyzer. That's also only a desirable thing. It would work without those things, but it works better and quicker with those things. Yeah. So the question is this better than textbook learning? I think it is, because it's you creating corpus and reading specific teaching and learning tools. Yeah? Corpus-specific tools to teach your text that you want to teach that semester. You're absolutely in control, but you do more of a facilitating job than actually a frontal teaching job and say, this is this is that, this is it. There are a lot of different tasks you can ask the students based on those tools that are not currently implemented, but because you're in classroom, you can ask them to do that, and you can quickly use the cunning use of spreadsheets in order to create new learning content, yeah? And new exercises. Students contribute real knowledge that you can use later on in other applications and better applications with the next year. Instead of you writing a control tree and setting it up, you're choosing the best student control tree, and then you don't have to do it in your next Computational class again, but you're using the results of the students the semester before. So their work is definitely not for the bin, but it's for something that you can use over and over again. And hopefully they like this, that they don't produce work at home that's actually used and not thrown away. And enables students to continue peer-to-peer work from home, which is not always easy, and I think which is not addressed by any of the big three content management learning system I've mentioned before. Not by Moodle, not by Sakai, not by Blackboard, aside from that they're able to write each other. So that's all for today. I try to do it very swiftly, so if you have any question, I do understand, and I'm more than happy to answer all of them, hopefully. Thank you. Yes, please.
I just noticed that in the site translation finder, the passage you found the same words on basically the te, kai, tong, but the real big words that matters, they are not the same as the original text. So is there any way to solve that problem?
Yes, the answer is yes, but it's also not a big problem. Let's go back to it and let's see it. So was it this one here? And let's go, for example, to the plague. Yeah. So, I mean, we do have Tomanga, Ethos, and so on. And then we have Ale, Ute, Pantos, Pollenusa, Legontes, Kakos, Hasye, Ek, Pemphe, and so on. That are words with meaning. It's not just Kai, Te, Hos, and so on. I would have to check on the individual level why this is. What it means is the words that are, that's why it's more than just a word search. Even if you think the same words, the common words between this and this sentence are only Te, Kai, Hos, and so on, that doesn't mean that the topic modeling only looks at them. This means that Ek, Pemphe has a similar word topic bag of words like Ab-Ek, Krife, for example, or that Legontes and Homologato are in a similar bag of words. So they don't need to be one-to-one the same word that is repeated. They just need to be words from the same bag of words. Does it make sense?
Yeah.
Yeah.
Thank you.
Other questions?
I'd be interested in this distance, topic distance visualization. What are the dimensions on the axis?
That is good questions. So what we have here is the visualization of the similarity. And the more light the color is, the more similar they are. What I do in the similarity, I always compare the passage itself, the passage that is before that passage, and the passages after that passage. with the passage that is most similar to that passage, and that one comes before and that one that comes after. And that means that this, of course, should always be the lightest blue, because those are the ones that are most similar. But I can also see that suddenly here I have lighter blue than here. So my assumption would be that the passage that comes after that actually deals with a different topic than, or it's a new passage. So we have here 249.2, and we have here 249.1. So it's actually, this is introductory. 249.1 is where he actually just said, oh, this is the plague and so on, and this is how it came from Egypt over here. And this is how he actually deals and starts with the passage. So we actually have a clear shift from the topic used in the text. And you can actually find this to find chapter borders. Here it doesn't work that well because 49.1 is a very introductory sentence. But in other chapters it works quite nicely. You can see how where passages start. Let's take maybe a more meaningful chapter. Yeah. So here we have 247.3, 4. So here we have a chapter border. Here we have something that is something that sends over from one chapter to another. So especially the one at the beginning of a chapter and at the end, the last passages there are often parts that are just used to transduce from one chapter into the other, and you can actually see that visually. So often the last sentence of the last passage of a chapter corresponds well with the first passage of another chapter. It's a very expensive way to find chapter borders. Computational expensive way. Does this answer the question?
Yeah, right.
Yeah. Other questions? Good. Okay. Cool. Then thank you very much for listening. I hope the students are still confident that we pick the side readings fairly. And yeah, thanks you all for listening.